Hello students, how you doing today? Hope you're having yourself a fabulous Tuesday. I got some nice artwork going on behind me. Check it out. Whoop. It's my daughter. It's Kyla. She's wearing yellow sunglasses. Let's get into our lesson today, shall we? Elliot Small. Today, so this is part 2 of a 4-part lesson. Yesterday we did solving systems using graphing. Today we're going to do the solving same systems of equations, but we're going to use a skill called substitution. One thing you're going to notice is that the problems I'm using in this lesson are the same problems we were graphing in class today. So I'm basically showing you a different technique to solve the exact same problems that we used for graphing. First example is y equals negative 6x, or excuse me, negative 6 plus 3x, and y equals 6 minus 3x. Now, in substitution, it's lovely when we have this y equals and y equals, because we always ask ourselves, what do we know about y's? Well, if y is equal to y, and if y is equal to y, that would mean that negative 6 plus 3x must be equal to 6 minus 3x. And now we just have a singular equation with only one variable. We just solved it, and using our algebra skills. I'd first add 3x to both sides here. That'll bring all the x's to the left. If I want to bring all the x's to the left, I need to bring all the numbers to the right, and I could do that by adding 6 to both sides. So I have 6x on the left side. On the right side I have 12. 6 times what equals 12? Divide both sides by 6, and 12 divided by 6 is 2. So we have the x-coordinate. Need the y-coordinate though. So we're going to plug this 2 into either one of these two equations. It does not matter which equation you plug this point into. I recommend using the equation that looks the easiest to work with. And in this case, I pick second equation. So I write that equation out, y equals 6 minus 3x. Everywhere I see an x, I plug in 2. So y equals 6 minus 3 times 2. Follow those order of operations, and you end up getting y equals 0. And don't forget to give your answer as a coordinate. X coordinate was 2, y coordinate was 0, and this is a good starting substitution problem. Let's take a look at example 2. Actually, I'll put it back here for drama. 3 seconds. Alright, example 2. What happens if the two equations aren't y equals variety? So the first equation, what is negative 2x plus y equals 5? And the second equation is x minus 3y equals negative 30. An equation like this, you're going to have to use some algebra, and you're going to need to solve either one of these two equations for either x or y. Now there's technique to this. It makes sense. You want to do the least work possible. You want to avoid fractions, stuff like that. So when I look at this problem, it looks like I could solve this first equation for y. It also looks like I could solve the second equation for x. If I did either one of those two maneuvers, it's going to be a little bit easier on me mathematically. Let's try solving the first equation for y. So I take negative 2x plus y equals 5. I need to solve for y, so I add 2x to both sides. And I end up with y equals 2x plus 5. And that was using the first equation. Now, if you use the first equation to solve for one of those variables, you must use the second equation in the next step. Once again, let me say that a second time. If you use the first equation to solve your equation for a variable, you must use the second equation on this next step. And now we're going to pull off the substitution. we're going to go through this equation, and everywhere we see a y, we're going to plug in what y is equal to, which is 2x plus 5. So x minus 3. Here comes the y. So instead of writing the y, I'm going to write what y is equal to, which is 2x plus 5, equals the same negative 30. This is an extremely important step in mathematics. If you plan on taking your math skills to higher level math, IB math, or into college math, this form of substitution is a form of substitution you're going to need to be very good at. You're going to need to master it. So if you really want to take your math to the next level, and this looks confusing to you, you're going to want to do a lot of practice until it feels like second nature. Because like I said, in terms of higher level math goes, this is an extremely important topic, what I showed you just now. Alright, now we have an equation. It's nothing but x's. So let's go ahead and solve this, well, x's and numbers. So let's go ahead and solve this equation out. I first distribute my negative 3 here. Negative 3 times 2x is negative 6x. And negative 3 times positive 5 is negative 15 equals negative 30. X minus 6x is equal to negative 5x. So negative 5x minus 15 equals negative 30. I add that 15 to both sides, and I get negative 5x equals negative 15. Divide both sides by negative 5, and it appears that x is equal to 3. And, alright, so we have this, x equals 3, and now we need to plug this 3 into an equation. Now, we can plug this 3 into this equation up here. You'll get the right answer if you do that. You could take your x, you could plug into this equation, you'll get the answer that way. But down here where I took this first equation and solved it equal for y, it already says y equals. So it would be a great step to use that equation. And you go y equals 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. So y is equal to 11. So my answer as a coordinate is 311. Now there are a lot of different ways of doing this problem in substitution. I showed you merely what I thought would be the easiest way to solve this problem using substitution. If you'd like to talk about other techniques, that would be a great question to ask at the beginning of class tomorrow. Alright, I have 2 more examples for you, but I don't want to do them all in complete lecture format. If you feel confident with your lesson at this particular point, I actually don't really have anything new to show you. The only thing that's going to be different in the next couple of examples is that there's going to be some fractions in the answer. So if you want to see some more challenging problems, keep watching. If you don't need to see more challenging problems and you feel ready to rock, we'll have more practice problems for you to practice on tomorrow. But if you are interested in seeing some more fun examples, check out number 3. Number 3 has fractions. Fractions. So let's say we had y equals 3x plus 2 as the first equation and y equals negative 3 over 2x plus 5 for the second equation. Hi, Kyla. We have both equations are y equals and y equals. So in this example, it's kind of like example 1 where we can set the 2 equations equal to each other. And then this 3 over 2 is what confuses people. Not confuses. People start making mistakes with fractions. And when people start making mistakes, I'm just like, let's work this problem out so that you don't have any fractions at all. Because the only denominator in this problem is a 2, we can multiply everything in this equation by 2, and the fraction will be eliminated. 3x becomes 6x, 2 becomes 4, negative 3 over 2 becomes negative 3, 5 times 2 is 10. You solve out this equation, you end up getting 2/3 as your answer. And like I said before, you can then plug this negative 2 over 3 into any equation you want. I used the first fraction, or the first equation, because this equation didn't have any fractions in it. Seems like it would be easier to work with. So I plugged 2 over 3 into the equation, and I ended up getting an answer of 4. So my final answer for this example is 2/3, 4. one more example to show you. And for this one, why don't you take a minute, see if you can pause this video, see if you can solve it on your own, and then we'll come back and talk about it. I have x plus 3y equals 6, and 5x minus 3y equals 6 as well. So go ahead, solve it out, and I'll show you my solution in 5 Elliott seconds, 4 Elliott seconds, 3, 2, 1. Hey Kyla, I hope you're having fun today, sweetie. All right, here's my work. Okay, I chose using the first equation and solving for x. And the reason I chose that is that it was the only variable in here that didn't have a number in front of it. So it's the least amount of work to solve it, to use the substitution. So I took the first equation, solved it for x, so I subtracted 3y from both sides. I then, because I used the first equation for the substitution, or to solve for x, I must use the second equation for the actual substitution. I rewrote the equation first, and then everywhere I saw an x, I plugged in 6 minus 3y. Next step, distribute the 5, add up those like terms, subtract the 30 from both sides, and when you divide both sides by negative 18, you end up getting an answer of positive 4 over 3 when you reduce the fraction. Then, I already had an equation that said x equals, and I am looking for an x value. Sorry, we're losing some contrast here. So I used this x equals equation. Everywhere I saw a y, I plugged in the 4/3. 3 times 4/3 is 4. 6 minus 4 is 2. So my x coordinate is 2. Put your answer as a coordinate, and your answer is 2, 4/3. And that's just a quick introductory lesson on substitution, solving systems of equations using substitution. If you have any questions about this lesson, be sure to circle those questions, bring your notes to class tomorrow, and ask about them. And we'll have another warm-up and some practice problems for you to work on with substitution. And I hope you have yourselves a great Tuesday evening, or if you're watching this on Wednesday morning, I hope you have a fabulous Wednesday. See you later. Bye-bye.